Hello, grade 11s. I'm going to be going through this chapter 28, differentiation of exponential and logarithmic functions. Okay, so just to get some things off the bat, we have that if f of x is equal to e to the x, then the derivative of that is e to the x. So e to the x is itself and its derivative. Okay, if we have f of x is equal to ln x, then the derivative of that is 1 over x. Now just remember, with these examples that we're going to be going through, we might still have to use product rule, chain rule, etc. Okay, just depending on what the functions we have. So if we go through example 1a, they are asking us to differentiate here. So y is equal to e to the 5x. Okay, so that's in this form here. So what we can do is we can say dy dx for the derivative, and we can see that the derivative of e to the x is e to the x. So we get here e to the 5x. But here comes the problem, is that this exponent here is a function of itself, which is 5x. And we need to use the chain rule for this. We need to still differentiate this inside function. And the derivative of 5x with respect to x is 5. So our final answer is 5 e to the 5x. Okay. Question B. Y is equal to e to the x to the power of 3. Okay, so dy dx is equal to, so the derivative of e is itself, so we get here e to the x cubed. But what now we need to do is we need to differentiate this function here, and the derivative of that with respect to x is 3x squared. So our final answer here would be 3x squared times e to the x cubed. Okay. Question C. Y is equal to ln 4x minus 5. Okay. So this is now in this form. So the derivative of ln is 1 over x. So dy dx is equal to, now the thing is with this function is that we don't just have x. We've got this 4x minus 5. Okay, so what we have to do here is we have to go 1 over, which is that, and then whatever's inside here, 4x minus 5. But now what we need to do, grade 11s, is we still need to differentiate this inside function. So multiplied by, and the derivative of the inside function is just 4. And then I can simplify that to be 4 over 4x minus 5. And there's the derivative of that. Okay, going on to example D. Okay, they're asking us to differentiate y is equal to ln 3x to the 5. Okay, because it's in that ln form, the derivative would be 1 over whatever's on the inside here, so that's 3x to the 5, then multiplied by the derivative of this inside, so that's going to give us 15x to the 4. Okay, I can simplify that to be 15x to the 4 over 3x to the 5, and things can cancel here. 3 can go into 15 5 times, then this x to the 4 will cancel with the x's at the bottom, and we're just left with 5 over x. Okay, question E. Y is equal to ln x squared plus x minus 1 to the power of 3. Okay, what I'm going to do here, grade 11s, is I'm going to apply my ln law. Okay, which says if you've got a power up here, I can take it to the front. And that is what I'm going to do here. So I'm not differentiating just yet. So 3 ln x squared plus x minus 1. Just go back to your Lin laws and you'll see we can do that. Okay, now I'm going to differentiate. So y is equal, or dy dx is equal to 3. Differentiate this ln and it will be times 1 over x squared plus x minus 1. Multiplied by the derivative of the inside, which is going to give us 2x plus 1. Okay, then I can just tidy up a bit here and we get 3, 2x plus 1 over x squared plus x minus 1. And there is your derivative. Okay, I'm going to go through number 2 now. I'm not going to do all of them, I'll just do a little bit of them because they're pretty much all the same. Okay, so question 2A. All right, they've asked us to differentiate f of x is equal to ln 3 minus x squared square root. Okay, so the first thing I'm going to do here is I'm just going to change the surd. I'm still keeping it as f of x. I haven't taken the derivative yet. So ln 3 minus x squared to the power of a half. Now, just like with the previous example, I'm going to apply my Lin law, take the half to the front, and we get f of x is equal to half ln 3 minus x squared. Okay, now I'm ready to differentiate. So f dashed of x is equal to a half 1 times 1 over this function, 3 minus x squared, multiplied by the derivative of the inside, which is going to give us minus 2x. Tidy up a bit here, and we get minus 2x over 2 times 3 minus x squared. And there's your derivative. Okay, going on to the next example, which is B. We've got g of x equals e to the sine 3x. Okay, so the derivative of e is itself, so g dashed of x equals e sine 3x. But now we need to differentiate that top, okay? And the derivative of sine is cos. So we get here cos 3x, but we still need to differentiate this inside function, and the derivative of that is 3. Okay, so this one was a little bit more complex, guys. Just differentiate your e, which is itself, then differentiate this function, which is cos, then you still need to differentiate that inside function, which gives us 3. Okay, so our final answer here would be 3 cos 3x times e to the sine 3x. Okay, let's go on to question C. K of x is equal to x squared times e to the 4x. Now over here I'm going to be using the product rule. We've got two functions times by each other. So k dashed of x is equal to, now we differentiate the first one, which is 2x, leave the second, plus leave the first, differentiate the second, times by 4. Now how did I do that? The derivative of e is itself, but then I must still differentiate that function, which is 4. Okay, then we can just tidy up a bit here, and we get 2x times e to the 4x plus 4x squared times e to the 4x. And there's our derivative. Okay, guys, I think I'll leave it there because the rest are pretty much the same. And that is it for the derivatives of E and ln.